So let's start with a particular process of training a model and the issues that are going to come in and how exactly we can resolve this. The first thing to do, of course, is to show, well, that the application can handle a variety of sources. And that's something that's going to happen inherently. You're going to work with a lot of different data sources. So it's very important for the application to also work with that. What I'm going to do here is, depending on the one-time cadence refresh, I'll come to this shortly, is of course ingest them. So the first aspect is you're going to take in data sources coming in from a variety of systems and ingest them into one specific system. Here is where migration induced errors can come in, and here is where migration validation is a critical use case. Main aspect here is that, as you can see, we're working with a variety of formats, variety of vendors, and if you would like to ensure that these are being combined correctly, that these are being migrated correctly, ensuring a full data comparison between the two is critical. This will come in handy when we discuss the cadence-based refresh as well. But here itself, the first step to do is to ensure that the migration is happening correctly. The next step is, of course, as you can imagine, to analyze the data. Now, when you want to analyze the data, you want to understand what are the different categorizations you would like to go ahead with. You'd also like to understand what you want to define as an acceptable value and an unacceptable value. At this point, any kind of profiling and analysis of the data set that you're working with is very helpful. Of course, an end data scientist is going to look at the data sets more closely, but a preliminary check that the application can provide is very helpful as well. And so profiling and analysis is another place where you would like to define any kind of quality checks. The next step is, of course, cleansing. Well, now that you have found the corresponding issues and you have defined what an acceptable value is and what an unacceptable value is, only thing left at this point is to find them and in many cases fix the records as well. Now this could be based on rules, this could be based on finding outliers, this could be based on defining your categories, and if anything is outside that category, either fixing it or removing it from your dataset itself. And that's where analysis and rules comes into play. Here's where analysis is not used just for defining these systems, but it's actively run on the data sets, regardless of how big your data set is, to make sure that the training data that you're going to put in, training and testing data, is accurate and it can be actually used in accordance to the expected values. The final step here is, of course, data validation. Now, there's a good question here. Well, I just cleansed my data. Why do I have to validate it again? Well, the main aspect here is validation is pretty important, as the model training process itself does not exactly tell you if the ingested file is that incorrect. Let's pick up an example here. If I'm working with a file which is expecting few categories and there is a value, say -1 in there, when I was expecting only 0 to 10 values there. At that particular point, many models are going to ensure that, yes, I'm working with, say, numbers at this point. It could also be 0 instead of -1. But 0 is an unacceptable value according to my system. But the ML model might just pick it up and train itself on that. And now you have some outliers present for model 0, and these records are incorrectly trained on. And so validation is important to ensure that if there are any incorrect records, you find them, and the definition of a correct and incorrect record is entirely based on the context of the model being trained on. Once you've done all of this, well, this is all deemed as part of the data massaging and preparation steps as well. And what you do at this point is now you have the training and testing files ready. If you would like to, you can have one more sanitization round. This is important. And if you're working with pickle files and other systems, again, it's still important to ensure that these files are in the expected format, especially if you're working with really large volumes and if the model training process itself is going to be quite heavy. So it's very helpful for you to define the rules right there and run validations on this one last time. And at this point, you start your model training process. The exact model training process is something we won't touch base on, as this is outside the scope of the data quality aspect. But after this particular model training process is done, once you're happy with the results that you have your trained model. That's all fine and good. So at this point, well, we have done a one-time refresh. Depending on how often you actually retrain your model, it's a one-time refresh done. And here itself, we have defined multiple points of failure or multiple points of issues which can incur a lot of cost and overhead as an end user. So our developer has now created the trained model, but this, of course, as you can imagine, is just one part of the story. Yes, developing a model can also take a good amount of time, but once the model is deployed, now the end user has to actually use it. And this is where real problems come in as well. It's going to be very similar to what we do in our training process, and that's going to be our model usage process. where yes, instead of a one-time refresh, now you're working at an ingestion layer, which is going to work, say, on a daily basis or a weekly basis or even a monthly basis, depending on your cadence. But now the main aspect is, well, this is refreshing data. This is going to come in and day out. Someone might just change the maximum amount of, say, length or column width for address now from 20 to 35. And now your ingestion layer should be able to handle it. If you have auto ingestion switched on, or if there's some auto trimming that's working inherently, now you're going to work with inaccurate data from the ingestion layer itself because of, once again, migration induced errors. That's one thing. Then, of course, instead of doing an analysis at this point, what you will jump straight into is the cleansing, given that you have already defined this data set and you have a good idea of what the expected rule sets are. So once again, a good part here is that if you're working with a system that can easily transfer rules from one system to the other, it's very helpful. And so that's the expected expectation here, is that, well, the data cleansing takes place automatically at a cadence interval where we find out issues and fix any kind of non-standardization that is found in the data set, regardless of the volume of data. And that's a critical thing, because at some points you might be working with, say, 100K records, and at other points you might be working with 1,000,000 records as well, depending entirely on your use case. But cleansing is pretty important. After cleansing, the other thing that we have to look into once again is data validation. Just because we have cleaned the data once does not mean that it's actually completely accurate. There's a good amount of profiling that you have to do here. You need to ensure that all the data sets that you're working with are exactly correct, once again, in the context of the AI. So if I'm not expecting 0 in a numeric column, that should not be present here. And if it's present as 0, maybe I've defined another rule set for it, so it should be reconciled into the expected values as well. And that's why data validation is once again a critical part of the system. Once we have done this, we have model-ready files. This could be the pickle files that are prepared within your Python script or any other scripts that you're working with, or say you're using an AWS or Azure-based system. You do see these files from time to time before they are ingested by the model. Before those 50 node systems or those 25 node systems are actually going to run the model in. Now, it depends entirely on the confidence of the end user here, but as I have personally also dealt with a lot of AI/ML pipelines, I believe that these model files should go through at least a routine check, especially on the fact that its expectations are having no strings, maybe working only strictly in numerics, having expected precision in some columns and not in the other, and so on and so forth. These type of validations are going to help you save a lot of time, because at this point, if there are some issues, you will have to rerun the model. So it's going to cost a lot. So it's much easier for you to run one final check on the model ready file as well, regardless of whether you have done data validation correctly. And for all of these use cases, the application Datagaps can actually help quite considerably. But the story is not done yet. Yes, we have our model ready files, and the application is going to push them to the trained model. They're going to get an output here, right there. But of course, there's a critical point missing, which is that, well, our machine learning model has given us an output, but at the end of the day, it's not working on strict logic. It's working on the output of a LLM, or in this case, a machine learning based system itself. Now, this is something that's ignored by a good amount of folks. But let's say, for example, you are working in finance and you have defined a prediction model to basically put stocks in on a particular value that's expected. Now, again, the model has a lot of weight and say in this, and there's a good chunk of it is automated. But what if you have defined guardrails on top of your model which are not working as intended? An example that I can think from my personal experience was in terms of a prediction marketing model that I worked with. So it was a marketing model that predicted engagement points, and many times, well, engagement points come with a budget. You can't really just contact people day in and day out. You don't really have the budget for that. And so now we need to ensure that, yes, while we have defined our guardrails in our configuration and training process, are these guardrails as expected? Do this particular output actually adhere to the expected business rules? Is it exceeding my budget expectations? Is it exceeding other aspects as well? And so here, validation of our output can be done both in terms of analysis as well as rule-based systems. In my experience, we have used rule-based systems and analysis as well. So that's something we can put here as well. But it is critical to make sure we sanitize the output of the model before we push it ahead to the subsequent process, especially when the subsequent process is also automated and can cause a lot of issues from that perspective. So that is basically terms itself as output validation that the application does. Finally, of course, further processing is a block that's deemed to define all those other blocks as well, but it's not done yet, because once we do get this output, Something that's done every now and then is the analysis of the output. Again, this is a little different from the validation aspect because the analysis is primarily done to define retraining parameters. Here is where data drift and model drift come into picture as well, because we would like to ensure that any kind of shift in the profile of the data that we were working with is being captured. A very simple example is that, well, if you've created a financial model for 2014, it's not really going to work in 2025. I mean, it's not even going to work in 2016 in a lot of cases, because the profiles and the aggregations, the expected values between the data set you had in 2014 versus the one in 2015 is going to be very varied. And keeping track of the differences between them is something that the application can help with as well, and something that you have to do yourself in terms of model and data drift capture. So yeah, this basically kind of sums up most of the use cases that we deal with. This is a typical AI/ML model pipeline, which works on a cadence of, say, weekly or daily basis. However, as we have segregated them into training and users process, you can define how you would like to use them.